Okay, so here we are going to do one more Lewis structure, and I will do some electronic bookkeeping, but we'll try and do this in a little bit better way, although sometimes electronic bookkeeping is the best one to do. Okay, so we'll take bromate ion. Bromate ion is not something that you encounter all the time, but still, anyhow. So here we have bromine and oxygen, and between bromine and oxygen, bromine goes in the middle again because bromine is lower in electronegativity. So then you have the three oxygens that go around the bromine. First, you form 3 bonds, okay, between bromine and oxygen. So you have at least one connection going for you. And then now you're like, okay, what am I supposed to do next? Well, you remember bromine actually has 7 electrons, okay? Bromine has 7 electrons in the valence shell. Oxygen has 6 electrons in the valence shell. So 6 times 3 is 18 electrons, and then of course here's the 1 electron, so we have a total of 26 electrons going for us, okay? So which means that we've taken care of 6 electrons, so that is 20 electrons. So what I will do now, okay, and then we'll count electrons again, is I'll go ahead and make at least 2 bonds more between oxygen and bromine. Why so? Because oxygen can have up to 2 bonds. Bromine can have up to 7 bonds because it is capable of having expanded shell. But oxygen can have only 2 bonds. So I will go ahead and do this. I can go ahead and put 2 bonds here also, okay, for oxygen and bromine. But then bromine will be left with 1 electron, okay, which is unpaired. And bromine doesn't like that. In fact, a lot of compounds don't like having unpaired electrons, so you should try to avoid it as much as possible. The only element that can handle lone pair of electrons is nitrogen. Okay, so let's not do that. So here is bromine, and I have added 2 more pairs of electrons, which means I have added 4 more electrons, so minus 4, and I'm going to go a little bit sideways here because I need the bottom space. So now I have 16 electrons. Now what I'll do is I'll go ahead and put in my valence electrons for oxygen, because these 2 oxygens here, this one and this one, they are octet happy, so then I can go ahead and fill the valence electrons, which means that both of them have 2 pairs of electrons left, and here we go for that. So total number of electrons on oxygen is 1, 2, 3, 4, 5, 6. 2 are bonded, 4 are not bonded. So I added a total of 8 electrons, so minus 8 electrons, and that gives me 8 electrons left over now, okay? So then with 8 electrons left over, I have to assign electrons to this oxygen, and I still have something left over for bromine, because bromine should have 7 electrons. So I have 1, 2, 3, 4, 5 on bromine. So here I can put 2 more electrons. That gives it the 7 electrons. So now I have 6 electrons left, and here goes my 6 electrons. So long all my electrons are accounted for, I should have the right structure. In some cases, maybe 2 of you may come up with a different structure, and that is possible. What is more stable structure will be determined when you do resonance, okay, and formal charges. That determines which structure is more stable. So if you're studying with a friend and you come up with a different structure, that is fine, okay? It's not a bad thing, it's fine, it's good to be creative, but it's also good to be stable, okay? And so find the right structure, okay? And we'll talk about that in a later pencast. All right, the other one I want to do for you is nitric acid. And again, there is a polyatomic ion in there, but I want to do the acid because I want to show you how the hydrogen is attached, okay, over here. Usually when you have an acid, then hydrogen is attached to oxygen. So which means that even though nitrogen is my central atom, the way I will do this is by putting all oxygens around the nitrogen, but no hydrogen, okay, around the nitrogen. The hydrogen that I have will go to the oxygen. And this is like a big hint, okay, when you're drawing Lewis structures for acid. So you I shouldn't say never, but you will most likely not put the hydrogen on the central atom, okay? It will attach to the oxygen here. Okay, so here we have nitrogen with 3 bonds, and nitrogen is capable of having up to 4 bonds because it has 5 electrons. So here I will do this, okay? I will put 1 extra bond over here. if I put one more bond, then I'm in trouble, okay, because then I will have more electrons than nitrogen. Right now I have 8 electrons, and that is perfect, okay. So remember what happened though, okay, because nitrogen should have 5 electrons, okay. So what happened? Right now I've accounted for only 4 electrons, which means that nitrogen should have 1 electron left over, okay, which means that 1 electron that is left over has to be assigned to something else, okay, in there, and that probably is going to have to be an oxygen, okay. So all right, so this is what we have here, and I still have to place my hydrogen, so I will pick one of these oxygens, and whichever one, it doesn't matter, and I will place my hydrogen with it. So now I will go ahead and place all my lone pair of electrons. So nitrogen doesn't have any because all of it is bonded, and there was one left over, okay, electron, which I have to deal with. But otherwise, or if you want here, let me go ahead and write this, okay, then I'll show you what we do with this. So 1, 2, 3, 4, 5 electrons. Oxygen should have 6 electrons. So 1, 2, 3, 4, 5, 6. Oxygen here has 1 electron that is bonded, 1 electron with hydrogen that is bonded. So 2, 3, 4, 5, 6. Okay, all electrons accounted for there. This oxygen, on the other hand, it has 1 here, 1, 2, 3, 4, 5, 6 electrons. Okay, so which means that one of the electrons here is unpaired, one of the electron here on nitrogen is unpaired. So this is what happens in nitric acid. This 1 electron is going to move to oxygen to pair it up, okay, because that gives it more stability. So which means that my final structure is going to look like this. And remember, when you write the Lewis structures, you have to write all the lone pair of electrons, okay, so which means you should write all of these, and if you don't write them, then your structure is wrong. So my last electron pair that I'm going to write here is between these two, so that is right here, okay, so that is my Lewis structure. It's not an ion, so I don't have to put square brackets, okay, but what I will do is I will check my total number of electrons. So I should have 1 electron for hydrogen, I should have 5 electrons for nitrogen, and I should have 18 electrons for oxygen. 6 times 3 is 18. So that means I should have a total of 24 electrons, okay, in this structure. So which means that I should have 12 bonds. Okay, so I'm going to see if I have 12 pairs, okay, over here. So here you can count with me if you want to. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All electrons accounted for, okay. So that's how you will do Lewis structures for nitric acid. You should try on your own, maybe sulfuric acid, phosphoric acid, something like that. Okay.